Welcome to the wonderful world of Network Address Translation, or NAT. Every engineer will need to understand NAT, or certainly every CISCO engineer and network engineer, maybe less important for server engineers. So, difficult one because NAT's mentioned in the CCNA syllabus, but it's also mentioned in the ICND too. So what I've done is I've tried to put as much information as I can in the first part of the exam, just in case they drill in for more information. But as we go along, I'm going to cover the stuff I'm pretty sure they will ask you in the exam, and I don't think they're going to ask you to configure it, although you never know. I think they're more likely to ask you to look at a NAT problem and decide what the actual issue is and why NAT isn't working. And really, we'll come to this at the end, but there's normally only a couple of reasons for this. NAT was created as a way to preserve IP addresses, and I've mentioned in earlier IP addressing lectures that panic set in when the powers that be realised that we were very quickly running out of IP version 4 addresses. So this is just one of those methods to make them last a bit longer. NAT is about swapping your internal addresses to an external address, another IP address. And if you're masking your internal host, it does actually protect them from the outside network. So it is considered a method of security, albeit kind of a secondary method of security. You'll normally have your NAT take place on the router, or sometimes firewalls will do your NATing for you. Alright, so NAT, you've got your host on the inside of your network. I haven't put any switches in this diagram, but you will normally have switches, your router, and then the internet. Your host will leave your network, going off to the internet, and it will have an internal address that is one of the privately available addresses that just anyone can use. When it goes out to the internet, your NATing router or firewall will change it for an address that can be routed on the internet. Now, you'll buy this address, or you'll be allocated it from your ISP, or it can be some sort of dynamically assigned address. But we don't really need to dig in how that happened. Your router will maintain a table, so it will remember which address from the inside was translated to which outside address, and then when the packet comes back from wherever it's been to on the internet, it will swap back from the outside to the inside address again. NAT terms, you've got your inside network as far as NAT is concerned, IP NAT inside, and your outside network. So this is just for the router to decide when to do a translation. The commands that you would configure on your inside interface, which is your fast Ethernet interface, will be IP NAT inside, and funnily enough, for your outside address, which is normally your serial interface, your outside interface is IP NAT outside, and this is applied on the actual interface. Alright, more NAT terms. I think these are a bit confusing, to be honest, but there's 4 references to the way the address can appear internally and externally on the network. I think have a look at this and write it down and learn the definitions is all I can say, really. So I'll let you read that for yourself. This is from our dual CCIE for ITAFA. He wrote down the definition of the inside local address, and this is how it appears. So pause the video if you want to watch it for a bit longer. The inside global address in reference to NAT again has its own definition. I'll look back at the diagram as well a couple of slides ago. And the outside local address, and I did mention the outside global is also mentioned as well, the outside global there. And there's the same diagram again, so the outside global, inside global, outside local and inside local. Alright, 3 ways you can use NAT. You can have one inside address configured to one outside address, and this is called static NAT. Obviously, a problem is only one device can have a conversation with the internet at a time. So, unless you've got a pool, you could buy 10 addresses that are routable on the internet, and that means 10 addresses on the inside could connect. You can have a pool of addresses. You can have many internal addresses, and they can map to one or more external addresses, and that's called dynamic NAT. and then you can swap loads of internal addresses for many external port numbers. So you can have one IP address, but it's actually using port numbers allocated to that IP address, and that's called port address translation. So static NAT, this means you've always got one address on the inside and it's always translated to the same address on the outside. You'll normally need to do this if you've got a mail server or a web server on the inside of your network. So basically an address that will need to remain constant. So here we go, here's an illustration. Your web server's got internal addresses, possibly not recommended really, but I'm just using this as an example, and your mail server, and they will always translate to the two external addresses. So I'll put a configuration here, pause the video, and just have a look at what the configurations are. But you do need IPNAT inside and IPNAT outside commands. You can have more than one inside address, and then IPNAT inside source static, and then the address to translate from and to after that. And there's the configuration there, just a larger size font. You must do lots and lots of labs, by the way, for static NAT and dynamic NAT, and also port address translation. So assign the inside and outside networks, and then add your translations, and you can have as many as you want, but you obviously need to have those to buy those external IP addresses. Dynamic NAT, basically you have a pool of addresses, a group of addresses, and you tell the router with an access list when you want those addresses to be translated, to have a NAT translation. Alright, so say for example you've got 3 hosts, you would have more on the inside of your network. They're going to leave the router, or go into the router and then leave on the other side. And you've got a pool of addresses from your ISP, numbers 200.1.1.1, and then all the way up to 16. So your inside addresses in this instance are 192.168.1 up to 3, and the outside addresses are from 1 to 16. And here's the configuration: IPNAT inside, IPNAT outside. You have to configure a pool, so you give the pool name a pool. Now in this instance I've given the pool name pool name. I could have called it Paul, How to Network, Fred, John, Ringo, whatever. So the pool starts off 200.1.1.1 and ends in 16. You would need to have 2 addresses in here, even if you have a pool of 1 address. I know that sounds strange, but it'll make more sense with the next configuration. And you need to have the net mask, which is the network mask for the pool. And then the next command, IPNAT inside source list 1. So that's telling the router to look at access list 1. And that will tell it which networks you want it to be natted, because sometimes you might not want a network to be natted. You add the pool name, and then the access list 1 is the network that you want to have natted. Finally, port address translation. So this is taking a port number instead of, or as well as, an IP address, but you can just have one IP address, and obviously there's technically over 65,000 available port numbers per address. So the configuration is exactly the same, however the router is doing an IP address and adding a port number to the end of it, so you can have thousands and thousands of hosts using the same external IP address for NAT, but just using a different port number. Configuration is exactly the same as a NAT pool, however you add the word overload to the end of the pool when you're doing the source list. Again, you really need to do a lab on this for it to make sense. Okay, common NAT problems, they're nearly always the same thing really. Almost always someone has forgot to put the IPNAT inside command on there, the inside interface, and or the IPNAT outside command on the outside interface. They forgot to write an access list, or they've put the wrong details in the access list, so they've put the wrong network number in. Or they've misspelled the pool name. The pool name is case sensitive. So if I wrote pool name, as I did in my configuration earlier, but when I put it in the access list I type a capital P then it won't work. You can troubleshoot NAT with the debug IP NAT command or the show IP NAT translations, and that will show you what is actually being NATed on the router. Okay, thanks for watching.